we are excited to present our project, Autonomous Greenhouse Caretaker Report. The main objective of this project is to monitor soil moisture, temperature, and humidity in real time and send the data to the Blink app. This reminds optimal plant growth and ensures plants receive the right amount of water, and it automates the monitoring. In today's world, where smart technology is transforming every field, this project is a step towards smart agriculture. It helps to reduce manual work, and it ensures to save water. And Autonomous Greenhouse Caretaker Robot, a smart system designed to revolutionize modern agriculture by automating greenhouse maintenance and monitoring. The Our project aims to identify the key challenges in greenhouse farming, such as inefficient watering, insufficient climate control, and high labor cost. By integrating IoT sensor, machine learning, and robotics, we provide a precise and sustainable solution for this problem. Our project has the key functions of monitoring soil moisture, humidity, and temperature in the environment, and it will water the plants if it is needed. So it is such a sustainable solution for the problem. And first of all, we have to understand what is a greenhouse. Greenhouse is a controlled environment where we can grow our plants. Over 30% of agriculture places separated for greenhouse. By the year 2021, it is calculated that 190 million revenue has been made through greenhouse, and by the year 2030 it will be increased to 270 million by the increase of 4.19% because of the reason of increased population, food demand. So greenhouse automation will be an sustainable solution for this kind of problem. In greenhouse, we can grow plants like tomato, lettuce, spinach, and fruits like strawberry, blueberry, and so on. For if you want to for we face problems like monitoring it. It will be time consuming and labor consuming. Monitoring every plant and taking care of every plant, it will be time consuming, and it is not possible by the humans. So we introduce our robot to solve these problems. It will monitor the plants automatically, like it will identify the temperature, humidity, and soil moisture level, and it will automatically water the plants. And it also alerts the user if any kind of problems occurs, and the user don't need to go to the fields to identify if the plant is good. This system works by collecting the real-time data from the sensor, processing it, and transforming it to the Blink platform. It ensures user for remote monitoring, and users can even set alerts if the moisture level is too high or too low. So let me give me a brief explanation about the key components used in this. An overview of the key components used in this project. ESP8266 microcontroller. The main goal of this microcontroller is to enable Wi-Fi connection and transfer the data to the Blink platform, which enables real-time monitoring of the environment. It is compact in size and it consumes low power, and it is cost efficient, so that's why we use this one. Next one is DHT11 sensor. It is used to measure humidity and temperature. It works by measuring the capacitor, humidity, and thermistor temperature. It measures the temperature and humidity, and it sends the data to the Blink app. Next one is soil moisture sensor. The soil moisture sensor, it is used to find out the water content in the soil. You can ask me like how it will identify the soil moisture level. It will identify the soil moisture level by identifying the electrical components, electrical resistance in the soil. The wet soil has low resistance and the dry soil has high resistance. By identifying the resistance level in the soil, we can easily identify if the plant needs water or not. These are the components used in this project. And next one is for software. We used Arduino IDE to program our model, and to program how microcontroller works, and these are the key components used in our project.
Hello, I am Lakshna. I am going to explain about the working of the project. The working of the project has 5 stages. I am going to explain each stages. That is, first stage is data setup. In data setup stage, the ESP8266 is connected to the Arduino through Wi-Fi, and the DHT level and soil moisture sensors are connected to ESP8266. This system initialize and behinds to collect the various types of data. And the second one is data collection stage. In data collection stage, it helps the DHT level measures the soil humidity and temperature, and the soil moisture sensors measures the water content of the soil, and ESP8266 measures and it collects various types of data in which it interprets the soil conductivity. And the third one is data processing. The data that is collected is directly converted to the percentage, in which it is very easily to make us interpret whether the soil is wet soil or wet moisture or dry. And the fourth one is data transmission stage. In data transmission stage, the soil that is being predicted, the process data is converted to the percentage and is connected to the Wi-Fi, and in which it allows to predict whether the values is correct, and also it helps to make us in real-time monitoring for us to connect with the measurements. And the last one is data display and monitoring stage. In monitoring stage, the DHT and the soil moisture helps to the plant app. It helps to connect the data, and it helps to check whether the soil is dry moisture and measurement is correct or not, and it helps whether the soil level is below a threshold. The system will send a alert. So these are the working of the project. Thank you.
Here I am going to discuss about the challenges and future works. Challenges: Wi-Fi dependency. Without a stable Wi-Fi connection, we can't be able to transfer the data to Blink app. Power consumption: ESP8266 have a continuous power consumption to maintain on outdoor use. Here the future improvements: they are automated water system to connect the relay system to water the plants. Data logging to store the long-term data for tracking and analyzing the plant growth. Weather integration: integrate the external data to optimize the watering schedules. We have a conclusion. In conclusion, the soil moisture and temperature monitoring using ESP8266 sensor is a partial and efficient solution for smart agriculture. By combining IoT technology with sensor-based monitoring, we can improve plant care and conserve resources. This project highlights the potential of automation and remote monitoring in the transferring traditional practices into smart and data-driven processes.